There's a way to demonstrate Bayes' theorem that's pretty cool because it's very dumb and it just relies on drawings and fractions. So let's say you have a universe of probabilities. You have an event of the type of A that is in this rhombus here, and an event of type B that is in the circle here. So a probability of an event A is the amount of stuff inside the rhombus divided by the universe of possibilities. The probability of not being A is being outside of the rhombus divided by all other probabilities, all probabilities that are possible in this universe, in this omega. Probability of B is the amount of things inside the circle divided by the universe of probabilities. The probability of not being B is being outside of the circle but inside of the rectangle. And the probability of A given B is the probability of being in this fraction of a circle. So it is the probability of being inside this fraction of our circle divided probability of being in a circle, as in P of A inter B divided by P of B. And the probability given that this is 100% probability of happening. The probability then of having B given A is the probability of being in the intersection divided by the probability of being A, given that A has happened. So one way we can prove a thing about Bayes' theorem is multiplying the probability of A with the probability of B given A, which are given. This is B given A and this is A. So it is the multiplication of rhombus divided by rectangle, which times fraction of a circle divided by rhombus, which is going to be fraction of a circle divided by rectangle, aka all possibilities that are in the intersection of A and B divided by all possibilities, which is basically the definition of A inter B. But B inter A is A inter B, so we can basically exchange rules, exchange what A does with B and what B does with A, and we have the same thing because it's the same thing for the intersection, which means it shouldn't be important the ordering, which means this is equal to this. This will give us a little bit later one way of proposing Bayes' theorem as an equality. So we get this picture, which is probability of B times probability of A given B, which is basically this intersection, which gives us that this is equal to this, which if we pass PB dividing, gives us that A given B is the probability of A times the probability of B given A divided by the probability of B, and probability of B given A isolated means that this PB gonna pass dividing here, so the probability of B given A is probability of B times probability of A given B divided by probability of A. And those are two ways of expressing stuff in Bayes. And we just did all of those with drawings. I found this in the internet. It's not my original concept. And since this was quick, fast, and a hurry, that is it. Bye for now.